Hello, my name is Neville Palmer, and I'm going to talk about the automation of a computer networking laboratory. So I'm going to discuss the use of the laboratory in education, and then the needs and benefits of automation of the laboratory. This was realised using Powwershell scripts, and eventually those scripts were aggregated into a graphical user interface, and it can be seen that this could be used to inform the curriculum. The primary users of the Computer Networking Laboratory are students on the Computer Networking degree programme. There are 22 computers in the actual laboratory itself, plus some spares, and there's also a computer that's on which the master image of those computers is maintained. We host virtual machines using VMware, so for example we can be running Windows XP, Windows 7, 2003, 2008, also running Linux such as SUSE, Ubuntu and Kali. We can also connect the computers to Cisco routers and switches and ASA appliances, but we also do use simulation and modelling software such as Cisco Packet Tracer, GNS3, that's Graphical Network Simulator, and also Riverbed Modeler. We also look at the operating systems, the network operating systems. Obviously we consider Linux and Windows. We look at administration using scripting and graphical user interfaces. So one example of one of these network operating systems stroke administration type laboratories are, well, first of all we would get the students to configure a DHCP server in Linux, and then we look at how we can develop a graphical user interface to configure the DHCP server. So we might do this using Qt Creator, and using C++, and we take the contents of some line edit boxes, and that's used to develop the output file, which will be a dhcp.conf file, which will be then used by a Linux DHCP server. So the challenges of using this laboratory are that it's shared amongst a number of groups, typically first years, second years, third years of the degree programme. So configuration management is one answer. We might want to do something like configure the loopback adapters on the PCs with their IP addresses for a particular laboratory, for example if we're using GNS3. We may also want to reclone the PCs or rebuild them, and I'll come to this in a moment. We might want to shut them down. We might even want to restart them. So what is rebuilding or recloning? Well, there are two methods of rebuilding or recloning. Rebuilding involves maintaining an image of the computers on a master computer, and that image is loaded up to is stored on a server using Ghostcast server, semantic Ghostcast server, and then we can deploy that image to computers in the laboratory. Now we can either deploy one partition at a time, or we can deploy the whole disk image. Obviously it's a lot quicker to deploy just the partition. For example, it might take 15 minutes to deploy a partition, whereas the whole disk might take at least 60 minutes. But recloning involves the use of VMware clones of VMware. Now we don't get the students to work on a VMware file. We get them to work on a linked clone, so that we can rebuild the linked clone. The students won't affect the master VMware image, they will just be working on the linked clone, and we just need to reclone that linked clone. So that's the quickest way of rebuilding the virtual machines in the laboratory, much quicker than downloading using Ghostcast server, for example. Now, automation. What are the requirements of automation? Well, rebuilding, as I said, from using the ghost images, or recloning those VMware linked clones. Also, shutting down. We might want to shut down late at night, or restart. So, for example, if we're going to rebuild the machines, we'd probably want to restart them from the server first. Also, we can schedule some of those tasks. We'd also like, as I mentioned, we'd like to configure some of those IP addresses on, for example, loopback adapters. We may want to install server remotely from the server, And also we might want to transfer folders. So for example, if we're setting up a time constrained assignment, we might want to download some files to the PCs in the laboratory. Now we can do this using PowerShell scripts. So quite a few PowerShell scripts were developed. Here's an example of one of them. This is this set IP is actually for configuring the IP addresses on loopback adapters in the laboratory, and we can use the Windows Management Instrumentation classes to actually find the loopback adapters and then set up the static IP addresses and gateways and the DNS server, etc. on the adapters, particularly the loopback adapters in the laboratory. And the use of PowerShell scripts has been found to improve productivity and efficiency in the laboratory. Without automation, for example, rebuilding one partition using Semantic Ghost would have taken at least 15 minutes, and obviously a lot longer if we rebuilt the whole disk. And configuring loopback adapters, this would involve configuring the IP addresses of the adapters on the master PC, uploading that image to the server, and then obviously rebuilding the machines using Ghostcast server. That would take at least 30 minutes. And also, if the computers are not turned off at night time, we calculated it would waste 3,200 hours of wasted energy. But automation means that we can reclone the virtual machines in less than a minute, all of them within the laboratory. And configuring the loopback adapters can be done within 5 minutes. And we also save that 3,200 hours of energy. So the problems that we encountered with use of script are that we ended up with a fairly large collection of scripts. So it became difficult to customize them. So if you wanted to change an IP address, you'd have to edit the file, for example. So this requires specialist knowledge to use. And it was difficult to keep track of some of those scripts. So we decided to put them into an application to aggregate the scripts in a Visual C# graphical user interface. And it became possible then to customize those scripts, so for example to change IP addresses or to change the computers to which they are delivered to. And this made it much easier to use. And also it's easy to develop in Visual C#. So here's what the application looks like. We call it the Remote Configuration Console, and you can see in this is the main screen here. We can set up the IP addresses on loopback adapters in the laboratory. Over on the right hand side we've got a list of the computers or PCs in the laboratory. So for example, if we want to configure the loopback adapters, we can actually load these from a pre-configured file. So we've got the IP address, subnet mask, gateway and DNS server, and we can either enable or disable them. And we can select PCs from a list on the right hand side. The computers that have got an XX next to them don't have connectivity, so they aren't currently probably not switched on. The ones that have got a PC next to them are the ones that we can select if we want to, and we can obviously deliver the configuration to. So here's an example of how the PowerShell script is constructed from within the Visual C# application. So this is a function called setAdapter, for example. We can see we've got a number of strings that are built up to form the PowerShell script command, and we can use a number of strings to make it easier for students to understand. When they're looking at this, they can see how the commands are constructed by doing one line at a time. So we first of all encrypt the password, and then we develop the credentials that are going to be used to run our script. Then we use the Windows Management Instrumentation to locate the loopback adapter, and we can either enable or disable it according to the checkbox on our form. Then we create a new PowerShell script instance, we add our commands to the script, and then we invoke the script. Here's the other half of that function. So if the adapter is to be enabled, then obviously we go and locate the adapter. We set up a static IP address and subnet mask, and then the gateway and the DNS server, and again create a PowerShell script, add the commands to the script and invoke it. You can see here that we've got a text box, and we're actually sending the commands, the PowerShell scripts, to a text box. This can be used for debugging purposes, but first of all we're replacing the sensitive information like the usernames and passwords, so that students and people looking at the text box won't see that sensitive information. So here's another example of part of the functionality of the remote configuration console. This is transferring folders, so we can set up a test share or share on the server, and then we can specify a directory where we want to copy it to on the destination PCs within the laboratory, and we can select all or some of the PCs to send that folder to. We can also do a similar thing to install software, so we can use a Windows installer file using a .msi extension, and we can send that to the computer, and we can use MSI exec to actually install software on the PCs in the laboratory. And we could also do other tasks, like we can shut down, restart the PCs, rebuild them, and we can also randomize MAC addresses, because when we clone PCs in the laboratory, the virtual machines tend to have the same MAC address, and which we need to randomize, and we can do that from the server. And we could also schedule tasks. So we can schedule tasks such as a daily shutdown. So in this case it's at 11 o'clock at night time, and we can reboot the computers at a certain time of day, and we can rebuild them, etc. And you can see in this screenshot that we've got a debug window. Now this actually takes the compiled, the constructed PowerShell scripts and puts them into a text box, and we can actually take the contents of that text box and we can put it into a PowerShell script file, and we can either use it for testing or demonstration purposes. So for example, here's one that we've taken the contents of that box, we put it into a file, and we can use it to test the PowerShell script to see whether it functions properly, or we could use it to demonstrate to students how a PowerShell works, and how we can construct it in our application, and then to demonstrate how it works. So the conclusions are that the laboratory automation has improved productivity, and the educational use using PowerShell scripts and then incorporating those into a Visual C# GUI has been also successful. And recommendations are for further development or improvement of the remote configuration console, but also for its use in education. The next step would be to develop some PowerShell labs, and then develop laboratory sessions that would demonstrate how to make or generate some graphical user interfaces, and then how you can use PowerShell scripts within those graphical user interfaces. So that's the next step. We would like to do that for our students, and we feel that we can use this program to demonstrate how that can be done. And here are my references, and thank you for listening, and if there are any questions.